Okay, another thing we're going to review very, very quick. We want to review the inequality symbols, you know, like recognizing inequalities and being able to write true inequality statements. So if we have to choose, these are the symbols available to us: less than, greater than, or equal to. Which one of those three am I gonna use for statement A to make it true? Greater than, yeah. Now that's a little bit tricky when you're dealing with negatives, right? A good way to get this straight, it makes it real simple, is you think of what graphical tool would you think of if you're trying to write an inequality? Number line, absolutely, right? Anything, if a number is greater, that means it's further to the right. If it's lesser, it's further to the left on the number line. That's an easy way to do it. What about B? Equal to. C? Less than. There you go. It's less than, isn't it? Right. -5 is further left on the number line. Okay. So it's less than. And then finally, D is a tricky one. Focus on D. Is greater than? Which one's further left on a number line? -3.5 or -3.05? -3.5 is further left, so it must be less than. There you go. Okay, good. All right, let's write these sentences real quick. The sum of 5 and y is greater than or equal to 7. How would I say that? 5 plus y. The sum of 5 and y would just be 5 plus y, or y plus 5. It doesn't matter, right? We have the commutative property for addition, so those can be flipped if we want to, or commuted. Is greater than or equal to? There's greater than. How do I make it? And I put a line under it to add the or equal to part, right? And then finally 7, okay? 11 is not equal to z. Well, this is how I would say 11 equals z. How do I make that not equal to? Okay, putting a slash through a symbol adds the word not, doesn't it? Yeah. 20 is less than, so that part's pretty easy. 20 is less than the difference of 5 and twice x. 5 minus 2x, good. Good job. Okay, looking at this page here. So two angles are complementary if the sum of their measures is 90. They add up to 90. If the measure of one angle is x degrees, represent the measure of the other angle as an expression in x. So a good way to think about these is to do it in steps. First, try to organize your thinking in words. And doesn't it make sense that if we wanted to represent that other angle, aren't we just going to be subtracting it from 90 if they both have to add to 90, right? Subtracting the first angle from 90. So we get 90 minus x. And you have it, right? That's no big deal. I mean, you have a few problems like that on the homework. Just kind of continuing to get used to the idea of turning words into mathematical statements, right? And then finally, last issue is combining like terms. In that first example, are those like terms? Can we combine those? 7yz plus yz. Give me thumbs on that. Thumbs up for yes, thumbs down. Okay, yeah, lots of thumbs up. Good. We can. Why? How do we know that they are like terms? What do you think? Go ahead. Okay, so it has to do with the variables, doesn't it? We can combine terms that have exactly the same variables with the same powers, right? Like if this had been 7yz plus yz squared, could we have done it? That wouldn't have worked, right? Because then the variables technically wouldn't have been the same. We would have had a z times a z here, z squared, and only a z there. So not only do the variables have to be the same, their powers or exponents also have to be the same. Okay, good. So that one can be combined. That's no big deal. We just get 8yz, right? 7yz plus 1yz is 8yz. What about the next one? It's not going to work, right? The variables aren't the same in each term. So they can't be simplified. What would I have to do in this example to simplify the expression? Really, we're just following PEMDAS, aren't we? If we work our way down, first we look at parentheses. Give me thumbs on this. Is there anything inside parentheses that I could combine to make simpler? No, nothing inside parentheses, right? Are there any exponents that I can simplify? Not really, right? There are exponents there, but they're already simplified, okay? So the next issue would be multiplication and division, right? Working our way down PEMDAS. Any multiplication? What is it? Okay, distributing is multiplication. Good. So we've got the -5 here. That would have to get distributed. So that's our first issue, right? Yeah. All right, so then we distributed, we worked our way down through PEMDAS. Last step would be A and S, so addition, subtraction. Anything we can do there? What do we do? Yeah, okay, good. We're combining like terms. So the like terms would be, it looks like we've got some x squareds that are like terms and some constants that are like terms, and you guys know this stuff. So then we just combine those and we're good. All right, this last one, same kind of deal, right? Everybody agree? Same kind of thing. We're just going to have to, there's no exponents, nothing we can combine inside parentheses, so we have to distribute and collect like terms. This time we have fractions though. What do we get when we distribute the 1/2? Okay, good. I distribute the 1/2. 1/2 times 4a, 1/2 times 4 is going to give us 2, right? So we get 2a, 1/2 times 6 is 3, so 2a minus 3b. Give me thumbs, that all makes sense? Okay. Over here we distribute what? -1/3. We include the negative. Okay, so -1/3 times 9a, what's that? -3a, what's the next term going to be? Minus 4b plus 1/3. Negative times negative is positive. And then finally we get that plus 1/4 on the end. Okay, last thing we can do? Combine like terms. So we can combine the a's. What's 2a minus 3a, everybody? -1a. How would we write that? Just -a. We wouldn't put the 1 out there, would we? So we get -a. How about the b's? -7b, I like it. And then finally we've got the 1/3 plus 1/4. Just, you know, real quick, just one more reminder. Talk me through that. How would I add 1/3 plus 1/4? What do I have to do? Common denominator, what's it going to be? 12, yeah. Smallest number that 3 and 4 divide into is 12, isn't it? How am I going to get a 12 on the bottom of the first one? For where? Top and bottom, good. Okay, so how about the second one? Good, top and bottom. And what's that going to give me then? I'm going to get 4/12 plus 3/12, which is, what do you know? 7/12. Good? All right, grab Chromebooks, go to work. You got homework to be cranking through.